everybody, I'm going to do a summary of section 1.4, which is about absolute value equations. So instead of going through every single homework problem on 1.4, I decided that I'm just going to do a few from each of the homework for this section. There were two different homeworks for this section. So the main concept that you'll need to know with absolute value is that it's the distance from 0 on a number line. So if I wanted to go from 0 to positive 5, I will travel 5 units. 1, 2, 3, 4, 5. And if I wanted to travel to negative 5, I would still travel 5 units. 1, 2, 3, 4, 5. Because distance cannot be negative, we can use absolute value to show that you can travel the distance in either direction, either going up or down. Now, I will talk about the problem that we did in class together. It was about you and your best friend living on the same street together, and your friend lives in house 15 on that street. And we're assuming that the house numbers go, or they change by units of 1. So, and the situation is that you live 8 houses away from your friend. And I posed the question, what are all the possible places for your house to be? Like, what are all the possible house numbers you could live at? So, a lot of people said, oh, I can go up. So that's 16, 17, 18, 19. So 1, 2, 3, 4, 5, 6, 7, 8. So I could live at house 23, or I could live down the street. So it's 14, 13, 12, 11, 10, 9, 8, 7. Or I could live at house 7. So the 15 was our starting point, which is something that we call the anchor. Okay? We use that word a lot. We call that the anchor. That's where we start. So we need to write an equation that shows that we started at 15, our house 15, and we're traveling a distance of 8 in either direction. So we came up with a sentence that described this. It was the distance from my house, which is X, to house 15 is 8. The distance from my house, X, because the original question was where could I live? And so the distance from my house, X, to house 15, which is our friend, is 8 in either direction. So if absolute value shows a distance, we have this rule that if you're finding the distance between two numbers, the distance between two numbers is the absolute value of their difference. So if I'm finding the distance between x and y, I'm going to subtract them and take the absolute value of that distance. So let's do that for our house problem. So our anchor will always be inside the absolute value bars. Anchor will always be inside the bars. Okay? So we're writing a sentence that says this: the distance from my house, x, to house 15 is 8. Is your equal sign. Is 8. Distance from x to 15. Distance from x to 15 is 8. So that's how we write the equation. Now we need to solve it. I need to see. Okay, so if this represents the distance from my house to my friends is 8, but in order to solve, or excuse me, in order to find the possible locations of my house, I have to be able to show that I can go 8 in either direction, 8 houses up or 8 houses down. So this is where we're going to write two equations. So I'm just going to rewrite our original. The distance from my house to house 15 is 8. And you notice that this 8 is positive because absolute value is always positive because it's a distance. Distance cannot be negative. So I like to draw two arrows to remind myself that I will have two equations. So we drop the absolute value bars, and you can write down the original one just as it is. This says that we could go 8 houses up because this is a positive 8. Or we can go 8 houses down because that is a negative 8. Algebraically, this shows that we can go 8 houses down the street. So then you solve both. And these are the house numbers that we found. Okay? So let me do one more for the 1.4a work. This is challenge 8 on 1.4a. We're going to be writing an absolute value equation, but we're going to be given the solutions first. It says that the shoulder heights of the shortest and tallest miniature poodles are shown. We have 10 inches and 15 inches. Okay? We're going to represent these two heights on a number line. And we're going to write an absolute value equation that represents these heights. Now, really cool thing is that when you add your two answers together, so 10 plus 15 would be 25, and divide that by 2, we get our anchor, which is smack dab in the middle of 10 and 15. Okay, so in order to travel, the distance from 12.5 to 15 is plus 2.5, and from 12.5 to 10 we'll go down 2.5. So remember, your anchor is always in your absolute value bars. So the distance from x to 12.5 is 2.5. And then when you solve, you will get 10 inches and 15 inches. All right, now I'll go to 1.4b homework. This is still absolute value equations. So I'll do challenge 1. So this says that the distance from 3h to -1 is 7h. And the reason why I said that it's the distance from 3h to -1 is because, remember, I said that distance will always be subtraction. So if I was subtracting a number, the number 1, what type of 1 would it have had to have been in order to get a plus right here? That's a negative. So the distance from 3h to -1 is 7h. We can just use our procedures for solving. We have to show that we're going 7h up and that we're going 7h down. Remember, when you have variables on opposite sides, you want to get those together by using the inverse operation. 7 minus 3 is 4. So 1/4. -1/10. Now, whenever we're just given an absolute value equation just to solve and it has no context or anything, we need to check our solutions. So if h is 1/4, so 3 times 1/4 is 3/4, plus 1 is 1 3/4, which is 7/4. The absolute value of 7/4 is 7/4. That checks. So now we do the next one, the -1/10. So it's -3/10 plus 1 would be 7/10. (7/10) does not equal -7/10, so this is not a solution. So our only answer would be the 1/4. I probably should label that as check. So with absolute value equations, you'll always have 2 different checks. All right, now I'm going to do number 2. Can't get my paper to move. All right, so this says that the distance from F to 6 is equal to the distance from F to 8. So we're going to go straight into solving. So if I wanted to show that we're going up on the number line, if I multiplied a positive 1, and what I mean by up, that's a positive 1, times the F minus 8, well, that's still F minus 8. Okay. If I wanted to show that I'm going down, you multiply by -1, and that will give us negative F plus 8. All I did was multiply this here by -1 to show the opposite direction. That's not true, so that's not a solution. So F equals 7, and then we have to check. 7 minus 6 is 1. 7 minus 8 is -1. And if you take the absolute value of each of those, 1 equals 1. And so that is correct. All right. Okay, I'm going to do 4 and 5. So challenge 4 and 5, it's about someone randomly surveying students at a high school about continuing dress code or not. And so we have a graph that shows that 68% oppose and 32% are in favor of continuing. The percent of error is plus or minus 5%, so the actual percent of those who oppose or favor could be 5% more or 5% less. And so we're going to write and solve an absolute value equation to find the least and greatest percentages of students who could be in favor. So we're going to use this percentage here. So let's draw a number line. If I know I'm going to be starting at 32% and I'm going to be going up 5 and down 5, well, up 5 would be 37 and down 5 would be 27. But we still need to show this using an equation. So the distance from x to 32 is 5. And then you would solve it just as I just solved all the other ones. Okay? That's all for 1.4. Now I'll go to 1.5 next.